Okay, so thank you very much. So today I'd like to talk about elections. So let's imagine a presidential election where we have three candidates, Anna, Benicio, and Carmen. And this table shows us the preferences of the voters. So for example, the first row of the table shows us, the first row of the table shows us that 40% of the voters prefer Anna to Benicio, and they prefer Benicio to Carmen. So who's going to win this election? Well, it's pretty clear that Anna is going to win the election because she gets 40% of the vote, which is more than any of the other candidates. But there's a problem here. And the problem is, if you look at the table, you can see 60% of the voters prefer Benicio to Anna. And 60% of the voters prefer Carmen to Anna. In fact, 60% of the voters think Anna is the worst possible candidate. So how did Anna win the election? Well, I think we know what happened here. Even though 60% of the voters think Anna is the worst possible candidate, those voters are split between Benicio and Carmen. So what's the solution in this situation? Well, typically in these situations, we have a runoff vote between Anna and the next best candidate, which in this case is Carmen, who got 35% of the vote. And if we do that, then you can see that in the runoff election, Carmen will win with 60%. So that's great. But there's another problem, which is now if you look at the table, you can see that in fact 65% of the voters prefer Benicio to Carmen. So it seems like the wrong candidate has won again. So what's going on here? So these examples show us two things. First of all, the plurality voting rule is a terrible way to elect a president, which is how they do it in the United States. And the second conclusion is that having a runoff vote does not fix the problem. And in fact, the plurality voting rule is also a terrible way to elect a parliament. Anthony already talked about this in the UK. So let's imagine a country which has three political parties, A, B, and C. And let's suppose that this country has 5 districts. And in each of the 5 districts, the preferences of the voters are as shown in this table here. So what you see is that in every single district, about 40% of the voters prefer the A party, and about 30% of the voters prefer the B party, and 30% of the voters prefer the C party. So under our plurality voting rule, what's going to happen in every single district, the A party is going to win. So the A party will win all the seats in the parliament, so it will have 100% control of the parliament and implement all of the A party's policies. What's the problem? You can see that 60% of the voters think the A party is the worst possible party. And in fact, when you combine plurality voting rule with regional representation, what you see is that smaller parties tend to get squeezed out of political power because people don't bother to vote for them because they never win anyways. And in the end, only the 2 largest parties survive. So this is sometimes called Duverger's law. But even if you have a situation where there's only 2 political parties, the regional representation combined with plurality vote can give you the wrong answer. So to see that, let's suppose that we had, again, 5 districts in our country. And suppose that the preferences of the voters are as shown in this table. And just for simplicity, I'm going to assume each district has 20 voters. So what we see here is that in the first 2 districts, 100% of the voters prefer the B party, whereas in the other 3 districts, about 60% of the voters prefer the A party and 40% prefer the B party. So what's going to happen under a plurality voting rule, the A party is going to win 3 out of the 5 seats, which means it's going to control the government. It's going to have a majority of the seats in the parliament, and it will implement all of the A party policies. However, you can see from the table that 64% of the voters actually prefer the B party. So that means the majority of voters are going to be very unhappy with the outcome of this election. So the good news is that Chile does not use that system. Chile uses something called the regional D'Hondt method. However, the regional D'Hondt method does not fix these problems. So to see that, let's imagine a country which had 25 districts. And suppose each of these districts is going to elect 4 representatives using the D'Hondt method. And now suppose that in this country there is one red party, A, and there are 6 ideologically very similar blue parties, which I'm going to call B, C, D, E, F, and G. Okay, and suppose that the preferences of the voters in these 25 districts are as shown in this table. So what you can see is in every single district, just over 40% of the voters like the A party, and the other 60% are pretty much uniformly, evenly split between the 6 blue parties. So what's going to happen under the D'Hondt method is that the A party is going to win all 4 seats in every district, so it will end up with 100% of the seats in the parliament and control the parliament. However, you can see from the table that 60% of the voters prefer the blue parties. So again, a majority of voters are going to be very unhappy with this system. So what's the solution? Well, one solution could be fully proportional representation. So in a system of fully proportional representation, the fraction of the parliament controlled by a party is exactly the fraction of the popular vote that that party got. So if a party X got 25% of the vote, then it gets 25% of the seats in the parliament. So this is a good system. However, it has some problems. So the first problem is that it makes political parties the gatekeepers to government power. So you cannot get elected except by being part of a political party, so there's no room for independent candidates. The second problem is that in this system, candidates no longer represent the interests of regions. In fact, they don't really represent voters at all, they represent the parties. And the third problem is something called Ostrogorski's paradox. So to see how that works, again, let's suppose that there were 2 political parties, A and B, and suppose the election was going to be decided on 3 issues: economic policy, environmental policy, and social policy. So this table shows us the preferences of the voters. So what you see in the table is, for example, 20% of the voters prefer the A party's economic policy, but they prefer the B party's environmental and social policies. And another 20% of the voters prefer the A party's environmental policy, but they prefer the B party for economic and social policy, and so on. So let's suppose that each person votes for the party that she agrees with on the most issues. So what's going to happen, you can see that about the first 60% of the people are going to vote for the B party because they agree with it on 2 out of 3 issues, and the last 40% are going to vote for the A party. So under a system of proportional representation, that means that the B party is going to control 60% of the seats in the government, which means it will have an absolute majority, so it can implement all of the B party's policies. But there's a problem. If you look at the table, you can see that on every single issue, a majority of voters prefer the A party policy. So that means a majority of voters are going to be unhappy with every single decision that this government makes. So what's the problem here? Well, we learned 3 things. We learned, first of all, that combining plurality voting rule with regional representation is a terrible way to elect a parliament. Second of all, the DONT method used in Chile is somewhat better, but it does not really fix the problem. Third of all, fully proportional representation is also somewhat better, but it also does not really fix the problem. So perhaps the issue here is that these voting rules are not using all the information about the voter's preferences, because we only look at each voter's top choice. We don't look at the rest of her preferences. So one possible solution is a more sophisticated voting rule where you give 2 points to a voter's top choice, you give 1 point to her second preferred choice, and the candidate with the most points in total wins. So you add up all the points. So for example, in this table here, we see that candidate B gets 45 points from the 45% of the voters who ranked him second, and he gets 2 times 35, which is 70 points from the 35% of the voters who ranked him first, for a total of 115 points, which is more than either of the other candidates. So that means that candidate B, let's say Benicio, wins the election. Okay? So this rule is called the border rule, and it has many nice properties, but it also has some strange behaviors. So to see that, so here are our 3 candidates again. So Anna, Benicio, and Carmen. Okay, so look at Carmen's score. Carmen only got 75 points, so there's no way that she can win this election, right? So she has no hope of winning, so she might as well just withdraw from the election. But if she withdraws from the election, look carefully, if she withdraws from the election, then Anna wins instead of Benicio. So the losing candidate withdrawing can cause the winner to change. So that doesn't make any sense at all. So that shows us that the border rule is sensitive to irrelevant alternatives. In this case, the irrelevant alternative is Carmen. But in fact, the border rule is not the only rule that has this problem. A famous theorem of Kenneth Arrow tells us that, in fact, any reasonable voting rule based on preference data is going to be sensitive to irrelevant alternatives in this way. Another problem is strategic voting. So now let's look at the supporters of Carmen again. Okay, so they actually prefer Anna to Benicio. So they might say, well, look, we know Carmen is not going to win anyways, right? Why don't we lie and pretend to support Anna, and then we can at least get Anna to win. So if they vote strategically in this way, then they can change the outcome of the election. So this shows us that the border rule, it can be manipulated by strategic voting. But again, the border rule is not the only rule with this problem. A theorem of Gibbard and Satterthwaite tells us that any reasonable voting rule can be manipulated by strategic voting in this way. So, in response to these phenomena, William Riker said, well, I guess that means that democracy can never be used to obtain a positive signal of what voters want. It can only be used as a negative device to get rid of corrupt or incompetent governments. But Amartya Sen said, well, perhaps the problem is that these voting rules use limited information. If we used more information or better information, then we could escape from the impossibility theorems, maybe. So to see how you could do that, let's consider the approval voting rule. So in the approval voting rule, you can vote for as many candidates as you want, but you can't vote for any candidate more than once. So you can't give more support to some people than others. So for example, suppose that there were 4 candidates, A, B, C, and D, and there were 8 voters, and the 8 voters vote as shown in this table. So for example, the first voter votes only for A, the second voter votes for A and B, the third voter votes for B, C, and D, and so on. We add up the votes for all the candidates, we get the totals shown at the bottom. Who gets the highest score? It's B, so B wins the election. So this rule is very good for finding a compromise which is acceptable to the largest number of people. It escapes from Arrow's impossibility theorem, and it is resistant to strategic voting. Another possibility is majority judgment. So in the majority judgment rule, the voters give grades to the candidates, and the candidate with the highest median grade wins. So to see how that works, let's suppose that the allowed grades were gold, silver, bronze, and lead. Okay, and suppose that the voters give grades to our candidates as shown in this table. So for example, the first voter gives gold medals to A and B, she gives a lead rating to C, and she gives a silver medal to D. So at the bottom, you see the median grades for the 4 candidates. Who gets the highest median grade? It's B, and so therefore B wins the election. Majority judgment is good in situations where there is an objective scale of quality or merit to judge the candidates. It escapes from Arrow's impossibility theorem, and it is resistant to strategic voting. A third possibility is called evaluative voting. So in the evaluative voting rule, the voters give the candidates scores on a scale of 0 to 10, and we add up the scores for each candidate, and the candidate with the highest total score wins. So for example, suppose that the voters gave the candidates scores as shown in this table here. So we just add up all the numbers in each of these columns to get the totals at the bottom. Who gets the highest total score? Well, it's candidate B, and so B wins the election. So this rule is good for aggregating the intensity of the preferences of the voters. It escapes from Arrow's impossibility theorem. If voters vote strategically, then it basically behaves like approval voting. So these rules I showed you so far are good for electing a president, but what if you want to elect an entire parliament? In that case, you could use weighted representative democracy. So the way that this system works is that each voter delegates her vote to one of the candidates in the parliament. And decisions in the parliament are then made through a weighted voting, where the weight of each legislator is just the total number of citizens who delegated their votes to her. So the nice thing about this system is that there are no political parties, and if you can see at the bottom, it avoids the problems of regional representation and proportional representation. At this point, you might be asking, well, which of these voting rules is the best? And the answer is, it really depends upon your goals, okay? It depends on the problem you're trying to solve. There's no such thing as one voting rule which is the best in all situations. So in a situation where you're trying to resolve a clash of competing interests or values, the best voting rule is probably approval voting or evaluative voting. In situations where you need to evaluate the objective merit of candidates, like let's say you're trying to select somebody for a job, the best rule is probably majority judgment. For the election of a parliament, the best rule, in my opinion, is probably the weighted representation rule. And to solve other kinds of problems, other voting rules might be better. So, as we've seen, democracy is complicated. But I hope that I've also showed you that a better democracy is possible. Thank you very much.